5 months ago, I ran the math and told you a budget AI box pays for itself in about 5 months. Today, I have to retract that number. The hardware hasn't changed, but open-weight inference costs, hosted by providers like Grok and Together, have collapsed. Prices that sat around $1.97 per million tokens are now 10 to 15 cents. That is an 80% drop year over year. This chart tracks the cost intersection over time. When cloud compute gets this cheap, the break-even math completely shatters. I have to take back the default recommendation to simply buy the box. Hardware decisions can no longer be based on what the silicon can do. They are strictly governed by the volatility of cloud economics. If you buy a local rig today, it has to mathematically earn its keep. I'm the bearded AI guy, and this is the finale of Poor Man's Spark. We are breaking down the human architect's foundational research on AI agents so you can deploy them correctly. Up until now, we've quietly blurred two distinct questions. Question 1, should you run agents locally at all? And question 2, if yes, which box do you buy? This comparative matrix looks at the hardware question. We have the $4,700 DGX Spark against the $1,500 Strix Halo and a used triple 3090 rig. Notice that all three systems operate in the exact same generation bandwidth class. That is roughly 273 gigabytes per second, regardless of whether you pay $1,500 or nearly $5,000. Because memory bandwidth is the definitive bottleneck for local agent generation, the budget box wins the hardware value proposition decisively. You simply do not need the Spark. Getting the hardware question right stops you from buying bottlenecked, overpriced silicon. But getting the economic question wrong will leave that exact same hardware sitting idle on your desk. Local hardware is a ski resort season pass. You pay a fixed cost upfront. Cloud is a day ticket, a variable cost per use. The metric that bridges these two models is your duty cycle. That is the sustained daily volume of tokens your agent actually processes. Break-even math divides hardware cost by the gap between cloud and local monthly costs. At 5 million daily tokens, a Strix Halo takes 38 months to pay back. At 100 million, it pays back under 2 months. The crossover is near 11 billion monthly tokens. The same budget box yields completely opposite verdicts based on one variable. The deciding factor isn't silicon, it's the mathematical intensity of your duty cycle. Buying a commercial pizza oven for your kitchen results in incredibly expensive pizza if you only bake once a month. This is the utilization trap. When you amortize a fixed hardware cost over a low volume of tokens, your effective cost per token skyrockets. Look at idle baseline costs. A local machine draws $3 to $12 a month just sitting there. At low duty cycles, that power alone costs more than a cloud API bill. Plus, this ignores unquantified risks, setup time, maintenance, and zero redundancy.
If you are running latency-tolerant, low-volume tasks without strict privacy requirements, forcing a local deployment burns capital with zero return. If the $4,700 DGX Spark shares the exact same generation bandwidth as the cheap builds, what exactly does that premium price tag buy you? You are paying for ecosystem friction reduction and maturity, not raw engine speed. This ledger maps the trade-off. The Spark Premium secures day one model support, mature CUDA, and the Tensor RT LLM stack. Hardware-wise, NVFP4 and FP8 yield a 5 times prefill speed increase. But despite this prefill advantage, a comparably priced triple 3090 rig beats Spark threefold on raw text generation. Premium workstation buyers are paying for immediate CUDA compatibility and fast prefill. They are not buying superior local agent generation throughput. You don't actually have to pick an exclusive side. A smart local clinic handles routine checkups in-house and refers complicated cases to a specialist hospital. AI agents should work the same way. Every major framework interacts through a standard OpenAI-compatible base URL. This means routing is a per-call decision. This topology shows the setup. Point individual requests at whichever endpoint fits. Keep a fast, small, local mixture of experts running for the massive volume of routine, sensitive steps. Then route only rare, highly complex reasoning and planning steps to a frontier cloud API. This hybrid architecture completely solves the utilization trap. The local hardware is constantly fed with cheap, high-volume work, heavily amortizing its fixed cost. By routing local for bulk and cloud for burst, you optimize speed and cost. The local versus cloud debate dissolves into a single cohesive system. Let's distill this entire architecture into a final mental model.
This flowchart uses 3 strict operational gates to dictate your deployment. Gate 1, if data privacy, regulatory compliance, or air gapping is mandatory, you strictly default to local hardware. Gate 2, if your sustained volume runs north of 300 million tokens a day, you default to local for cost efficiency. Gate 3, if the task is latency sensitive with massive context windows, you default to cloud APIs. If your workload is mixed, requiring both high volume and high reasoning, you build the hybrid architecture. Running this precise checklist protects engineering teams from making expensive, emotional hardware purchases. Memory bandwidth improves with every single hardware generation. Overinvesting in a high-end local machine today is a depreciating bet against next year's cheaper, faster silicon. Before you buy, calculate your actual daily token volume and drop it in the comments. Most architects severely overestimate their requirements. These hardware findings are new research, built strictly upon the foundation of the Human Architect's book, AI Agents in Action. Most deployments do not require local hardware, but when privacy or volume demands it, the poor man's hybrid box is the definitive way to build it, without spending like the data center you're trying to avoid.